cloud.
Okay, welcome to the September 16th, 2025 session of TAPR-HamSCI technical session. My name is Dave, KB0S, and this week I've been continuing to work on reorganizing my computers. I had a little pre-session with Dave Witten to test my configuration since I put a new operating system on this computer and it works. And actually I'm getting in my earphones stereo, which I didn't seem to notice before. So that's kind of nice. Anyway, next on the list is Nathaniel, W2NAF. Go ahead.
Thanks, Dave. Same as always, just continuing to try to keep things going at the university and keep all the projects moving along. I think it's coming. It's definitely keeping me busy. The most exciting thing that happened over the past week is I was invited down to the Delaware Valley Radio Association, which is in Ewing, New Jersey, and I got to give the presentation about ham-sized space weather we can do together, where I showed off the personal space weather station and things like that. And Joe Taylor is a member of that club, so I got to hang out with him and I got to talk with him about it, and that was really fun. And I got to see their really nice little station, and they are interested in putting up a personal space weather station down there. So I think that's all very exciting. Let's see. And just a message from Michael Howen that I saw just came on. Michael, I just sent you an email. Back to net.
Okay. Next on the list is actually Bob, W1XP. Welcome, Bob. Any comments?
I'm trying to unmute.
Oh, okay.
Good evening, everybody. This is my first foray on this session. So I'm just gonna probably sit back and kind of get a feel for how things go, but I have the loan of a Whisper Demon from Nathaniel, and I got it on last Thursday, and I've been it's a little bit of a problem with the antenna. I was trying to use a loop, and it doesn't have enough gain. So, well, we know how to build gain, but um, it's going to take a little time, and I've got some traveling in the future. So,
Yeah.
but it seems to be working reasonably well, I guess. I don't know. There's obviously a problem with the low F end, the low frequency end. The noise floor is well above the antenna noise. So, but I am copying some stations down on 630. I don't know if that's of any real interest, but it's of interest to me because I have a 630 station. So,
Well, very good. Yes, we are interested in all the different frequencies that Whisper Demon records. Well, welcome. And we usually do a roll call and then we go to just an open discussion after the roll call. Try to keep the roll call a little on the shorter side. Next on the list is Clint, KA7OEI. Go ahead, Clint.
Hi, yeah, been doing a little bit of radio stuff this week. I was did the VHF contest, and this is an old picture of my transverter. It's much more cluttered now since I added power amplifiers and TR relays and stuff. But anyway, hadn't fired that up for a couple of years, and it had been sitting in the closet, and something got set on it, and I had to figure out why it didn't lock anymore, but managed to get that taken care of. It's pretty old school. Also, I did a bit of as I'm wont to do, I did a bit of sleuthing and was observing that a little bit of background. I have been asked on several occasions to help identify KORM problems, and one of the local hams has a neighbor who has solar of the wrong brand. The wrong brand is SolarEdge, and they have the tendency to put out spurs every 200 kilohertz. In fact, I will take two. I won't take too long here, but just enough to get the thing. But this is kind of what it looks like. Every 200 kilohertz, you see the spur, and and if you zoom in closely, you end up seeing many carriers like this. So the question I had in mind was, do these things propagate? And sure as hell they do. This is from the Northern Utah Web SDR. This hump here is from who knows where, but this is the sum of probably thousands of rooftop systems propagating at some distance. And I know this isn't local because the Web SDR is located a long ways, miles away, and there's a mountain in the way from even the nearest tiny town. And when the conditions are bad, these are not present. But you yourself, if you have a quiet enough location, well, actually, what you can probably do is find any frequency in a ham band that ends in .2 and go less than a kilohertz below it, and you will hear these. So if you ever want to do communications on any ham band, avoid anything between 199 and 200 or anything like that on any HF band. But these do propagate, and I was able to detect these easily all the way from below 30 meters to about 15 meters, which is when I ran into an MUF problem. So there you go. More than you wanted to know.
Yeah.
Anyway, back to you.
Okay. Next on the list, we have Dave K W6OQ. Go ahead, Dave.
Yep. Greetings from Los Angeles. As usual, I'm just here flying the wall, see what I can learn. Thanks.
Okay. Next on the list is Dave Julian, WB9YIG. Go ahead.
Good evening, folks. Not much going on here. Just been doing some cooking and what have you, and so I'll just sit back and enjoy the program tonight. Thanks a lot.
Okay. And next on the list is Dave KD0EAG. Dave Whitten. Go ahead.
Hello, everybody. I've been occupying myself mostly with writing code and learning how to use some of these brilliant new things, AI things, to generate documentation, which it does great, and except when it breaks. And but it does some of it very, very well, and that's but it's taking a while to master it. That's all for me.
Okay. Next on the list is David McGaw in 1HAC. Go ahead, David.
Oh, good evening, everyone. A number of things have been going on. One is our local radio club, Twin State Radio Club of New Hampshire and Vermont. We just had one of our members do a presentation on FPGA programming, in particular in radio use. And some were surprised how many of us actually knew what FPGAs were, but of course they've been around for quite some time, and a lot of us have had cross paths. But you never know where the next programming resource may come from. I know that from time to time our system needs some FPGA programming. I'm continuing to work on our satellite ground station, and actually there are a couple of things I'll mention. I ordered a satellite rotator interface box from China. It came in fairly quickly without tariffs. And I also ordered one of the RF Zeros, which comes from Denmark. It came in without tariff, so I'm pleasantly surprised. And one last note, we are extremely dry here. I'm surprised we aren't getting static electricity problems. But my area right here are basically our 4 towns in right around me are in extreme drought. We have no idea what's going on, but the Northeast is in a very heavy, very serious drought situation right now with no um, indication of any rain coming soon. But one thing that it is, well, it's not strictly giving us clear skies, but there were apparently aurora last night. I don't know if anyone saw them. By the time I heard about it, it was about midnight local time, and it had already passed. It was like between 10 and 11 local time. What was that? About 2 to 3 hundred UT. Apparently, it was pretty intense, but short-lived. But the wind is still there. We just have to get the BZ of the wind to line up right, and maybe we'll get some more tonight. But more shall be revealed.
Very
Back to
good. Next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. I was working on the new VLF server or system and rewriting the scripts, backing up the 96 kilohertz data from the Raspberry Pi, encoding it to FLAC, and transferring it to the external hard drive for archival. And it was a bummer because unfortunately the website that the server would or the system would uplink to is down. So there's no quick way to check via web interface whether there was periodic emissions or dawn chorus last night. Unfortunately, I did not have the system running. I didn't get a chance to finish what I was doing, so the system was not capturing. So unfortunately, there was probably dawn chorus and periodic emissions that I missed. So that kind of illustrates the importance of these systems, these natural radio missions. They often come along unannounced. So it's important to have these systems ready to record them. And this was a similar event to April 10th, 2022, when during the middle of the night, the storming level went from 5 all the way to 7 and then back down. And there was a dawn chorus event. And I was hoping that there would have been a dawn chorus event last night. There was aurora spotted in Pennsylvania. It was weak emission, of course. Obviously, you had to use your camera to actually see it, but it was definitely there, and it was actually pretty bright in a lot of the cameras, but it was definitely there. Vincent described it as a watermelon aurora, where the red was sandwiched in between two green bands. But anyway, what I would like to talk about tonight is the results of Elmer's test, but I see that Elmer isn't here. I also want to talk about the digital RF and the possibility of encoding VLF data in digital RF. So I would like to talk about that tonight as that's part of the project. That's all I have. Back to the net.
Okay. Next on the list is Christina Collins, KD8OXEZ. T. Go ahead.
Hi friends, how's it going? I wanted to put out the link for the charrette where we've been collecting data. There's a link in the chat there. It's a little web form on the HamSCI website for any thoughts that you have on how you'd like to interact with PSWS data or features that you'd like to see in the API or the different ways that data is accessed, ideas for visualization, pretty much whatever you got. So please do send in your feedback over the course of the next month or two. We're going to be collecting everything, kind of going over it in November. You can submit the form more than once. And we're looking forward to hearing ideas from the community so that we can consolidate those into our software development requirements over the next few years. Other than that, in Radioland, I've been working on just a bunch of visualizations. Some stuff with magnetometers. Today I've been working on a visualization of ionoson data, so I'll let you know if I pull that one off. And got some papers coming up on the Eclipse campaign that we ran in 2024, for which I think some of the people on this call did data collection. So we're getting all of that consolidated and all of the data uploaded, and a paper talking about the lessons learned from that citizen science project, some of them scientific and a lot of them human factors. So very excited to get that out into the world. And then the other thing on my radio list is planning to attend the RCA symposium in November. So I don't know if anybody else will be here, but please drop me a line if you will. I see Nathaniel waving, so that sounds grand. All right, that's all I got. Back to net.
Okay. Next on the list is Michael Howen, AC0G. Go ahead, Michael.
Good evening, everybody. Not too much to report on this end. Just wishing everybody a good evening.
Okay. Next on the list is Phil Karn, K9Q. Go ahead, Phil.
Hey, Dave. Nothing really to report for the last week because I'm recovering from surgery. Seems to have been a complete success, but it's going to be a while. Recovery from it's going to be kind of slow. So anyway, back to you guys.
Well, our best wishes are with you.
Oh, thank you.
And next on the list is Scott, N5TNL. Go ahead, Scott.
Hey, I spent the week finding, fixing, and creating minor bugs, and that's about it. So back to the net. Thanks.
Well, those are all things that need to be done. So
yeah.
Next on the list is Tom, N5EG. Go ahead.
Oh, good evening, Dave, everyone in the group. 2 weeks ago, I think I finally got some design rules that'll allow me to finish layout of the circuit board. I'm trying to match it up with JLC PCB's design rules. And that leaves some interesting issues in differential traces. But I've got some that I think will let wires get routed between connector pins. Last week, I was in Everett, Washington, went to the GNU Radio Conference, GR 2025. Interesting. And notable sessions, there was a 2-hour session on GNU Radio 4.0, which is, bet you didn't know GNU Radio is used in particle accelerators. But there's a group in Europe doing that, and they've made massive changes to GNU Radio, apparently all for the good. It's been in process about 3 years. There may be a similar period until it's ready to go. There was a good presentation on using GPUs in GNU Radio, and there's a block available that will allow you to export data from a GNU Radio flow graph to a GPU and back again in a demo where there's about a 10x speed up in the particular flow graph. Tremendous amount of tweaking required to get any performance improvement. So you've got to count threads and indexes and counters and GPU cells pretty carefully, or it doesn't work. There was a session on FPGAs in GNU Radio, and this is outside of the RF NOx stuff that Edis uses. This was general purpose FPGA data import and export from GNU Radio flow graph. There was a session on precision in carrier amplitude analysis down to hundredths of a dB, and how to do that, how to account for scalloping and other errors in FFTs. Very good session there. Edis Radio is 20 years old. There was a 20th birthday party for Edis, and Matt came and spoke about how we got started and how Edis Radio got going. So all in all, pretty good session. It was in Everett, Washington, about 20 miles north of Seattle. That's right at the outside limit of driving range in one day from Medford. So real good session, and back to the group.
Very good. I believe Paul was there too, at least for a little bit.
Oh, he was? I didn't, if he was, I didn't see him.
Okay. And last on the list is Rob Robinette. Rob, I'm not hearing you. Get mic muted.
Hello. Okay. There, I found my. Okay. Well, sorry, I've shown up late, so I don't know what else. I'm sorry to have missed everybody else, but I've been mostly, I've been working. Well, put up a transmitter on 22 meters. I've been transmitting for about a week. A 5 milliwatt. That's the legal limit on the unlicensed band. It's 13.55 megahertz, 22 meters. And the first part until yesterday, I was running a vertical dipole, full wave vertical dipole. And yesterday I strung it up horizontally at about, maybe 5 meters. I don't know. It's not as high as I'd like it to be, but anyway, in both cases, I mean, it's kind of amazing. I've gotten whisper reports from the Canary Islands and from Australia. So it's all pretty low SNRs, but and of course it only briefly opens to those directions. But anyway, it's been fun, and I've been I haven't transmitted in a long time, and hardly like maybe 67 years. So so anyway, I'm preparing for some upgrades up at I have a colleague. We're going to go out to KFS on Wednesday and do some work out there. So a bunch of other stuff, but it's that's it for now. Back to Ned.
Okay, well, I think I've called on everyone, unless somebody else has jumped in the middle. And if not, we're open for general discussion. And Jonathan had some comments he wanted to talk about. So I guess we'll turn it over to Jonathan for a little bit.
Yes. So it looks like Elmer is not here. But so what I wanted to mention was he did some testing, and he found that that as you increased the capacitive reactance at VLF frequencies, VLF noise power line harmonics reduced, but as you decrease, HF emissions increased. He found that as you, if you use a capacitor that exhibits a high capacitive reactance at HF frequencies, HF emissions reduced, but power line harmonics at the natural radio band increased, which I kind of knew that's what would happen. So we need to discuss that further with him. The other thing that I wanted to discuss was the possibility of the conversion of VLF data into digital RF. So today what I was doing was I was looking at digital RF a little bit more closely and looking at the documentation. I was under the impression that it also included a signal processing suite, which it does not. And Nathaniel corrected me on this. It is simply a storage format. And how the signal processing would work is that you would have your data stored in digital RF, and you would read that data into Python or some C program or whatever you're actually using to do the signal processing. And in a lot of Nathaniel's cases and the cases of HamSCI, it would be Python, and the data would be read into Python, and the signal processing and visualization would be done with SciPy and Matplotlib and other sorts of other sorts of things. So and I was also in the process of reviewing the manual, and another thing that I was interested in was how digital RF handled compression, lossless compression of data. And what I found was in the general HDF5 format, the data would have to be broken up into chunks first. And then you can apply various compression, they call them filters, or at least that's what the documentation page said, where you could use different types of compression that you want. For example, zlib or other types of compression. And Nathaniel mentioned that digital RF uses gzip compression with a setting from, I think it was 1 to 9, or whatever. And so I was reading this, and I wanted to get more familiar with digital RF, because Nathaniel, I know that you had an interest in having VLF data converted into digital RF. So this is what I wanted to talk about, specifically with the digital signal processing capability that's already in VLF-RX tools. And a lot of those utilities which do that processing and visualization, they're already there in VLF-RX tools. And VLF-RX tools does have a storage format, a time-stamped PCM format, custom. And it can also do lossy compression with Vorbis and streaming VLF streams over the internet, and it can also do FLAC compression for archiving. So that's kind of what I wanted to talk about, that with all of these tools and utilities already in VLF-RX tools, if we convert to digital RF format, basically what would have to happen is that the student or the researcher or whoever that's using this data would have to rewrite the analysis in Python. And to get the same result out of the utility in VLFRX tools. For example, the natural radio event detector. That's a very specific thing, which requires a lot of specific. It's not. It required a lot of like special analysis, specifically PCA to look for rising frequency tones, and a comparison of curves that were captured to the Eckersley curve to actually detect whistlers. So this is one function that, like, if you want to do this in Python, like, this is not a trivial thing to do, but it's already there in VLFRX tools. Same with the spheric processing. Processing of spherics is obviously that can be done in Python, but it's already there in VLFRX tools, and it's used in a live lightning location network. So I wanted to discuss that further. Nathaniel, if you have any comments on it, but
sure, I have some comments, Jonathan. I think you know what I'm really hoping is that all of the systems from the personal space weather station network, whether they're VLF or they're you know, they're the Whisper Demon system, at least the part that's recording the spectrum, and or the magnetometer data, that they all end up in a central database that is searchable, findable, and reusable. Now, my original thought before I necessarily understood as much about VLFRX tools as I do now is that it seemed to me to make sense to pick a common, a common storage format for all of the spectrum data and try to store it all in that format. Now, I do fully appreciate your comments on the complexities of these different signal processing tools and how well they've been vetted and how they are kind of specialized to that particular ecosystem. And that is incredibly valuable. And, you know, that's, you know, so what I think might make sense is talk to Bill Engelke, and maybe it does make sense to have the VLF data stored more in a format that is native to the VLFRX tools in his database system. And that may not be too difficult for him because he's already handling, you know, he handles digital RF for the HF spectrum data, but then he uses a completely different format for the ground magnetometers and a completely different format for the grape ones. So he is used to handling heterogeneous data sets. So I think probably the best thing to do is to talk to Bill Engelke, you know, and actually it's good Christina's on listening to this conversation too, because she's also going to be she's also really important in these decision making on how we're handling things on the Alabama server. But I think that's probably the way forward.
Right. Yeah. I think that's a good idea too, because like we could definitely make a tool or utility which would convert VLFRX tools data into digital RF and back.
Yeah.
I can't because I'm not a programmer. And
Yeah.
unfortunately, the author of VLFRX tools is not with us anymore.
Yeah.
So we can't ask him.
Right.
So
Yeah.
this would be something that someone would have to look at the source code of VLFRX tools, understand it, and then find a way to take that data and put it into the hierarchical format of digital RF,
Right.
along with various metadata and things like that.
Right.
I mean, like, if I was a researcher, right, and
Mm-hmm.
I was doing VLF tailored research,
Yeah.
want to use these VLF tailored tools instead of having to rewrite them all.
Right.
And especially since I know Paul's skill and ability and the quality of his tools, the complexity and the ability of his tools,
Mm-hmm.
it is in my opinion nothing short of amazing. This I mean I'm it's not that I'm biased, but Paul was so gifted that he was able to do these like complex things so easily, and all anybody has to do is look at his source code and understand what his software does, and then they'll see how valuable it is. And the good thing about his software is that, like when talking to Bill, it would be so easy to integrate, to get VLF data and process it and create visualizations, plots, um, uh, 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 different sorts of VLF tailored data so easily via scripting and its programs.
Mm-hmm.
Because what at least my vision was for the personal space weather system server was to have, so sites would not only upload data in the traditional like grape sense that they would upload spectrum data, but they would also stream low bandwidth data, audio, Vorbis encoded audio, that's time stamped, up to 16 kilohertz, that would stream to the server, and then the server, that stream would be run into the event detector, where it would detect your natural radio emissions. It would go into various tools. For example, what I believe the wideband spectrum analyzer tool, which created that power spectrum plot, which many of you have seen, of the whole VLF spectrum, and it could also create like other sorts of plots as well, and something also to do like a cross correlation plot. You could take multiple timestamp streams, Vorbis encoded streams, from different VLF servers and try to correlate them, and you could create correlation plots, which also was on Paul's website. So that's kind of my vision, was to have this data available, because it's extremely useful. But under the hood, to actually create it, it's actually quite simple because of how easily scriptable his software is. And it's also lightweight because it's written directly in C and uses all the C libraries. Whereas if you include Python and digital RF, you're kind of adding on extra processing power and different layers and all that stuff where where to create the visualizations, you could do it easily with some bash scripts. So that's why that I was I was actually looking at this and I thought, well, geez, yeah, we can make a converter and that might be useful, but it just seems like we're doing extra work that we might not have to do. And
Yeah.
and the good thing is with how documented Paul's tools are, I can understand that for many people, the documentation page could be a little daunting because yeah, there's a learning curve and all that stuff, but it's written in a way where it's easy to understand, and he kind of it's written so like you could it's kind of written where you you have your differential equations lecture, right? And all the problems are done on the board, just like examples of what to do. And then the real work, the homework, where you have to kind of think and you use your brain to come up with different ways to analyze and play around in this and that. Like, it's a good exercise. The software is kind of like a good exercise in that. So there's a lot of like educational value that comes from this, which would be good for any researcher trying to use this data. And I obviously would be available to help any researchers. Maybe I would be doing some of the research too, but there might be students or people who might be interested. So I mean, that's why they wanted to bring this up. But I will definitely get with Paul, and I will or with Paul. I
with Bill.
Bill, yeah, I do wish I could get with Paul, unfortunately, but yeah, we'll have to get with Bill. We'll have to have another meeting so I could kind of give a kind of like a high level presentation or just to cover this stuff on a high level, so everyone is on the same page. And Christina, I hope that I was able to kind of give a good idea of what I had in mind and what I believe would be useful to someone actually using this data. So that's why that I wanted to bring it up tonight.
I think that sounds really good, Jonathan. Christina, do you have any comments?
Oh, just yeah, I think making sure that we're connecting up as much as possible with various parts of the open source RF ecosystem is exactly the kind of thing that we want to do and get into that specification. So any thoughts on support for VLF RX tools? Any thoughts on support for GNU Radio? Please put them in that charrette list. They will absolutely get into the mix. And yeah, whatever.
And I know that you've already submitted things to the charrette, which we are very grateful for, Jonathan.
I was about to pop it open and take a look for myself.
Well, yeah, and so I mean, that was I wrote that in the haste, unfortunately, but it was to kind of give an idea of what kind of data would be going in to the server and what would be processed and visualized and all that, and actually this brings up something else that I wanted to mention. Today on the VLF group, they were talking about a mirror of Abilene.org, because it unfortunately went down a couple days ago, and I was working with Anirban, who was the PI of the ILDN, the Indian Lightning Detection Network, and he has some friends who were very glad to host a backup, a mirror of Paul's website. So, and there were there was one of them, Stefan, who has a VLF server that uplinked to his website, and he was saying that he was wondering if there was going to be like another website to uplink this data, and the good thing about this is that these guys, they already have their VLF servers or systems installed and running, and would love to be able to uplink this data and have the data visualizations available on a website, easy to navigate, listen to the samples of the event detector and look at plots and everything else. So it's very useful to the VLF community, which also would be very useful to the academic community as well. And what I wrote in that submission was kind of like a high level bullet point of the kind of data products that would be available on Paul's website, which would be those things. And I will, so when the time comes, we will have a meeting. We could discuss this further. I could give you some scripts. We could work together, and then get the VLF part working, at least like uploading of spectrum data, and also the streaming part where you could uplink stream to the server, and then it would store the data in a buffer, and then we could set up the event detector and then the plots and then various things, which I could work with the guys who are actually doing the a code for the web interface and all that stuff. So we could get this up and running and working, because this will not only will this be a good resource for everybody, but it'll also continue Paul's work, which is very important to do. Now that he's not with us anymore. So yeah, when the time comes, we will work on this further, and we'll get it going. And it's I don't think it's going to be that big of a project. Yeah, when I don't know, maybe next month, Nathaniel, or
Yeah, I think there's a few places. I think what might work really well is if you we schedule one of those Fridays that you're here in Scranton on campus. We can schedule, let us know ahead of time, and we can schedule a meeting with you, me, Christina, and Bill, and then we can just have a meeting like that to kind of outline things.
Okay, and I'm also going to be working on like a mini version of this on my server at home, just so I could get the scripts right, and I could get everything working the way that it should.
Yeah,
because unfortunately we don't really have a copy of like the back end stuff that was running on Paul's server.
Yeah,
we were able to use wget to make a complete mirror, which worked great, but for the back end stuff,
Right.
Running VLFRX tools, obviously that couldn't.
Yeah. wget's only gonna get you so far.
Yeah.
Yeah.
So I kind of have to figure out like what the what he actually used to create these plots, and once we do that, I kind of have a better idea of like how it should be set up, and I think we could get something going. And some of our first beta users would be the guys that were originally uploading to Paul's server, because they already have these systems running, and all we have to do is give them a link, and they'll set it up.
Yeah. I think that sounds really good. I guess like you said, so did you lose all that backend stuff when the website went down?
Yeah, none of that stuff was really public because the PHP code that Paul used,
right,
like there was some backend PHP code that was not public.
Right.
But another good resource that we have is we have a Nirban, because we do have access to his backend code, which Paul wrote.
Okay.
And so just to kind of get things up and running, we could kind of borrow some of that code, and then we could get this server up and running where people could start uploading it, and they will have a repository for their data to go. But we have to make the decision, though, that the one thing that we have to do, or what we have to decide on, is the raw spectrum data. So, for example, at say 32 kilohertz, that's like 10 gigabytes a day of raw spectrum.
Yeah.
So at 192 kilohertz, even if you have one, these systems will have one channel, but if we have, say, systems with an H field receiver, which would have multiple channels, so we're going to have to figure out like are we going to back up all this data, because it's going to use a lot of storage, or do we back up? Now what Paul did was Paul had a backup of data sampled at 48 kilohertz. And that's good, but here's the thing. I'm sure a lot of you remember the confirmation of gravitational waves. That was it was announced in, I think it was 2017. The study by Paul Schofield, he and his gravitational wave detectors, he had two, and so he contacted Paul and asked for VLF data. He didn't know why, but he found out much later on. So Paul asked for VLF data, and what Paul believed, which I would love to talk to Robert, was he believed that he wanted to check at the detection of the gravitational wave, were there any spherics which could have overloaded the detector and caused a false detection. And since Paul had GPS timestamped data, VLF data, which was a good thing for him, because he could check and he could verify that there weren't any spherics going on at that time. The issue was that that he wanted higher bandwidth data, and Paul didn't have it. However, Mike Smith, who runs a VLF server in Forest, Virginia, he captured his data at a no. Paul only had 20 days, but Mike Smith had 3 months worth of data, and he also had it at 192 kilohertz. So, and with that data, Mr. Schofield was able to make the determination that it was an actual gravitational wave that came from 2 colliding black holes. And this was exciting for the whole science community, that like something that Einstein talked about was actually proven, which tends to be a trend. What he talks about is always proven. So this was something that was proven, and it was done so with the help of this VLF data at the where he had enough data storage, and he also had it at the higher sample rate. But that runs into, you need bigger hard drives and things like that. So when we have a lot of these receivers going, that's something that we're going to have to think about and come to a decision. What do we do?
Yeah.
So, yeah, that's
yeah.
all I wanted to.
I think this is all really good, Jonathan. I think it's really good you're thinking about all of this. And yeah, I know I was pretty hard about, making sure it was digital RF before, but, from listening to a lot of what you're saying, and also from seeing how the Alabama system's working, everything, I do think that it doesn't make sense to have a hard and fast rule that it has to be digital RF. And I do think it makes a lot more sense to have a good discussion with Bill Engelkey and Christina and myself, and really map out a good way to handle this data properly.
Right, and the one of the good things is that even though Paul's server isn't up anymore, we still have ILDN as a model, and I think ILDN as a model is a great place to start. And since we're working with ILDN anyway, it's just a natural progression of things. So I think that we can get this to where it should be.
I think that's really good.
Okay, good. Okay, I mean, I don't really have anything more to talk about. I think everything was already mentioned, and then now it's all about all the follow-up discussions and all that stuff.
Great. Yeah, I think I totally agree. So yeah, let's maybe, if you want, I don't know, I know next week when you come up, we're planning on meeting to talk about how we're going to be kind of splitting up the different VLF receivers, and reviewing the budget and everything. And then maybe when you're there, we can schedule a meeting with Christina and Bill 2 weeks after that. And if that works for you.
Yeah. I think that'll work great.
Okay, great. So yeah, we'll go ahead and do that.
Okay.
Thank you so much, Jonathan.
Mm-hmm. Thank you.
Yeah. It's after 10 here, so I need to go in a minute, but I know Christina wanted to talk to me, so I might just hop over to a breakout room with Christina, and I'll say 73 to everyone else, unless there's anything else. No. All right. Thank you, everyone.
Bye.